name is Owen Woods. I'll introduce myself in a minute. My talk is called Renovate or Rebuild. It was inspired by the fact that I've been involved in lots of legacy systems over the years. And the thing that's always distressed me a bit is there's clearly a key decision at some point, which is, are we going to fix it? Or are we going to put it into care and maintenance and build a new one? I've been distressed a number of times by the way that decision is made. And so I structured, it's not even a process, but more a philosophy as to how we might make that decision. Because I realized what tended to happen was people without a lot of technical background were making that decision, which is why it often ended up being vendor driven, or purely cost driven, or driven on emotion, or driven on last time we tried this, it was terrible, without a lot of deep thought. So I thought it would be worth solving that. That's what I call the million-euro decision, because most of us have ended up in a position where your system is a little bit like a Heath Robinson machine. It is working pretty well. After all, it's running the business. That's almost the definition of a legacy system. It's actually running the business. And you can change it. It's not that change has entirely stopped, but you probably do need to be a little cautious at this stage. You need to know all the moving parts, and you need to know some of the strange hidden dependencies that to the untrained observer might not be entirely obvious. So it is perhaps time, as it's quite hard to get people to work on the platform, possible probably to get a vendor to adopt it, as it's quite difficult. It might be time to think about its future. And then one morning, some senior manager, who obviously wants to make a name for themselves, decides, let's rewrite the whole thing. That for me is one of the scariest moments in computing, because actually I think that's a really dangerous thing to assume that we could do, is a clean sheet rewrite. Anyone who's done one would have had all the problems, such as rebuilds that get stalled halfway through, either because the money runs out, or it's harder than we thought, or we suddenly realize that there are technical constraints we can't overcome, or we manage to build the software and then migrating the workload across to it is really, really. When I worked for large banks, we had a number of systems that were very old. When you ask people why they were still there, they'd say, well, we built another system to replace it. And 95% of the workload moved across reasonably well. And then we got to the last 5% and realized the cost of it was going to be so high, we couldn't justify adding those features and doing the migration to the new system. So we've still got the old one as well. So we've got some of the costs of the old one and all the costs of the new one. That's quite common. And also just, we're not very good as an industry at estimating cost. Now, I would argue that's the same in most engineering industries. If you ask a chip manufacturer how much it cost them to design their last microprocessor, they can tell you at the end, not at the beginning. Very few of them know at the beginning what it costs to design a microprocessor. But certainly in software, we have a very, very bad reputation for working out how much it's going to cost. So as costs spiral, clearly these projects, if they're not running production workload, they become very attractive things to cancel. On the other hand, if we continue with what we've got, which is quite complex, aging platforms, that's pretty risky too. They're probably not tested all that well. They're hard to get to production. They probably don't use modern technology. They might have security vulnerabilities. It might be hard to patch if new security vulnerabilities come along. So there is a decision to be made. It's not just a question of clean sheet rewrite or replacement. Briefly, my name is Owen Woods. Leave the E off the front, pronounce the rest. I'm from Belfast in Northern Ireland originally. I'm an independent consultant today. Prior to that, I spent about 10 years in the software engineering services industry, working with clients and for a moderately large company called Endava. Then before that, 10 years in big banks, where I got a lot of my experience dealing with difficult legacy systems. And before that, I had 10 years working with products, some of which even still exist, which is possibly remarkable. Certainly quite nice that some work lives on. The whole renovate rebuild thing, I've always noticed is that the decision is made on really lots of emotions and typically loads of assumptions. I'm always amazed how fast people make this decision. I'm not suggesting the senior manager comes to the room and says, let's rewrite it, and everyone goes, yes. It's not quite that fast. But people do seem to make this decision really very, very quickly. But very often it's a decision people regret. Now, to be fair, with 2020 hindsight, they might have regretted both decisions. But very often I have observed it's one that doesn't end well. It's quite rarely a happy story, actually. So the question that I kept turning over in my mind while I was involved in these slightly ramshackle decision processes was, it seems to be an inherently technical decision. Could we use architectural thinking to help us do it? Before I go on, just a bit of context, because modernization means different things to different people. There is code modernization, which we typically call refactoring, except people call all of this refactoring, but that's proper refactoring, as in people like Michael Feathers are experts on this, Ken Beck and others, experts on safely modifying code in a really structured and safe way. Then there's software architecture modernization. That's what people like me do. That's for a single system, saying what do we do at system level to modernize it. And then there's enterprise architecture modernization. If you're aware of Nick Tune's work, architecture modernization, he very much works at enterprise architecture level. Have we even got the right systems in the organization before we start modernizing them? And so lots of things like strategy and event storming. My interest really and expertise and this talk are all in the middle, in the software architecture modernization part. Don't know why my slides aren't moving. That's what was meant to happen. My expertise is in the middle, and that's what I'm talking about tonight. It's really the entire structure of a single system, not an entire swathe of systems, sort of thing Nick works on, or indeed the detailed code refactoring. Of course, the real decision isn't should we renovate or should we rebuild. We've actually got a whole spectrum of options, and I think this is the core reason that the decision goes wrong. We can do tactical improvement. I've done this many times. This is where you haven't got a grand vision for where you're going. You know you've got some problems. New problems emerge over time, and you fix them as they emerge. It's very tactical stuff. You say, we have a database performance problem. We're going to fix it by changing the structure of our database. Quite a big change. It's modernizing it, but it's very much a single point in time. And we can do that for ages and ages. I've worked on systems that did this for years and years and years. Then there's more strategic improvement. We're probably still doing individual bits of work, but we've got some plan as to what the overall scheme of work is. We've got some clear priorities for how we're going to order that work, and we've got a backlog. We know what needs to be done. We have agreed that there's more than one thing needs to be done, so we're going to organize that into an improvement program. And that's the kind of thing where typically there's some improvement program over several years, there's a budget assigned, and we sort of burn through the budget making individual improvements. Then there's the incremental rebuild. That's where we actually want to replace the system, but we want to do it step by step. We don't want a big bang. We're going to do it triggers broom style. We're going to change every piece of the system, piece by piece, and at the end we'll end up with a new system, but at no time will we have two systems running in parallel. We'll always retain one system. And you're all thinking, that sounds complicated. Yes, it is. That's one of the downsides. And then finally, we've got greenfield replacement or parallel rebuild. So we build an entirely new system while we're also keeping the old system alive, and we migrate workload over to it. And all of these, of course, have strengths and weaknesses. I'm not going to read the slide, but the tactical improvement, it's easy to get started. You can normally do it without asking anyone. It normally doesn't require a grand plan. It almost by definition doesn't have a grand plan. The cost is very incremental, but so is the benefit. And actually, you can just end up not much better off, actually, despite having put quite a lot of effort into it, because there was no grand plan. Strategic improvement, more manageable risk, more money, very incremental. That's good because you can show benefit as you're going. One of the biggest dangers with greenfield. But it often gets stalled because priorities change. Yes, we've got this backlog of improvement work and we'd like to get on with it, please. Yes, but this sprint, we have to get these features done. How about next sprint? I'm sure that'll be fine. And then next sprint comes, of course, and what happens? There's a few critical features. We've got to get those done. But we will get to the improvement, we promise. And after 6 months, you're wondering when the improvements are ever going to happen. Because there is no definite program with dates. That's a big danger. Incremental rebuild, that's where we're identifying well-bounded technical change, but we've got a very clear long-term direction. We believe we know, we have a strategy anyway. We think we know what the system is going to look like in 2 or 3 years' time. We've done all this work. But we're going to do that piece by piece. So, for example, we're going to replace the trading engine first, and we're going to leave everything else. And then we're going to change the database model. and leave everything else. And then we're going to look at the inbound feeds and leave everything else, and so on. The problem with this is it's a relatively high risk strategy, arguably, because it's quite complicated to have old and new components in the system at the same time. When we're replacing the trading engine, we're probably going to have two trading engines for some period while we move workload internally. We're still doing migrations. They're just less scary than the big bang ones. So this one is quite complicated. The problem I've observed with it is not that we can't deal with the complication, it's that without realizing it, we slow ourselves down. Every functional change in the system now just takes longer because we've often got two bits to think about in parallel, or we've got, for example, data synchronization, or there's just something difficult about it. And then parallel rebuild, in theory, this is the best one to do. Best long-term outcome, it's relatively straightforward in the sense that you build alongside an existing system, you don't need to worry about all the constraints. You get regular software delivery, although you may not be using that software, and that's quite a big risk. But actually, in terms of delivery risk, actually getting benefit from it, I'd argue it's probably the highest risk because the migration is normally very complicated and you have to build often most of the system before you can migrate much workload onto it. So whenever budgets need to be trimmed, these systems, these programs are nearly always top of the list for trimming. So what I've observed is actually the two that are probably the easiest to sell and do, though none of this is easy, are the strategic improvement and the incremental rebuild. Those are two strategies I've had the good luck, privilege, bad luck, I'm not sure, to use both of those during my career relatively successfully. The big question is, what does success look like? Because unless we're very clear about what we're trying to achieve, clearly there's a chance we're just going to build a new system, renovate a system, do lots of rebuild in place, without actually pleasing anyone very much, possibly apart from ourselves. But we are probably the least important people to please, unfortunately. This, of course, is stakeholder analysis. And that is a core architecture skill. So that's one of the reasons I think architecture type people, whether they're called architects or not, need to be involved in this decision so that you don't get one person who is the loudest person in the room driving the decision. So I think it's an architecture-driven decision because you need this stakeholder knowledge and experience, but it's not just that. You also need lots of good communication. Lots of people will be impacted by this. Everyone will have an opinion, and lots of people will need to be sold on the plan. And lots of people will need to be kept up to date with the plan. So you need to think quite carefully about how you talk to them. A structured approach normally benefits it very much. You need quite broad technical knowledge and good technical judgment to make these decisions and also follow through and do the programs. That tends to mean senior engineers. And it's inherently, like most hard decisions, about identifying and making trade-offs between normally suboptimal options. It's very, very often picking the least worst option rather than picking the brilliant option. And again, that's very much a skill that senior technical people who do architecture tend to have in spades. So what would an architecture-driven approach look like? I keep this really, really simple. This is just about a process, but only just. Step one is working out where you are. What is the reality of the situation we're facing? And that's often not clear. So we've done quite a bit of work on that. Everyone's got a view. Most people have an assumption as to where they are that may or may not sync with reality. Step two, why do we want to change it? Actual benefit. And again, if we have five stakeholders, we ask five stakeholder groups, what benefit be of modernizing this system? We'll almost certainly get at least five answers. Once we think we know what the benefits would be, what options would we have for delivering the following strategy, but also more detail of the actual technical options. Then every technical option has the risks, constraints, things we can and can't do, and trade-offs. And it's really important we understand those before setting out. Again, tend to fall in love with one of the options and think, well, definitely want to do that one. It's really, really important that we understand what the implications of that are going to be. What risks are we going to have to manage that really early? What won't we be able to do? And the fifth step is we want to get the stakeholder community to make the decision. Obviously, we want to guide it, but we sometimes lose sight of the fact that these systems are not ours. They belong to the people who pay for them. So we need to make sure that the stakeholder community makes the decision. It's just that we don't want to abandon them without adult supervision. They need led through this process and to know how to use all this information so that they get to a good decision.
It's also the case that if they actually took the decision, it turns out to be wrong, they can't blame you.
There is that as well. Yes, there's politically, it's always better to make sure everybody said they agree. So what are those 5 steps? Step 1, understand where you are. That is, what's the context you're making the decision in? There's 4 bits of this I think are really important. What are the critical concerns of this system? What is this system all about? What's really important to the people who use it, operate it, pay for it? What state is the code in? That's sort of self-evident. Nearly everyone thinks of that one, but it is important. What state is the code in? And that's probably rather, these days, hopefully rather more than a simple static analysis. What quality attributes do we need? So how fast does this need to be? What security constraints do we have? How scalable does it need to be? What regulatory compliance needs do we have? And what's the gap between where we are today and those? What are we going to have to meet in terms of those in the future? And then what's the organizational and technical context of this system? If, for example, is it connected to everything or is it actually quite standalone? That can have a massive, massive impact on the decision. So the context is, what is the system connected to fundamentally? Where does the system sit technically? What's the team context? Is the team ready for the challenge? Do the team think this is a terrible idea? Do the team just want to be left alone? Do the team want to do? Is the team strongly biased towards one of the options? What skills do the team have? What skills would they need? Then there's the organizational context. Where does it sit in the organization? If this stops, gets switched off, or fails, what stops? If it's our marketing graphics production for Instagram, that's clearly a different level of criticality to if it's our main trade feed to the financial regulator. So we need to understand that organizational context. Mind you, if the graphical delivery to Instagram is of direct interest to the CEO, that may actually be quite an important organizational context for us to understand. Then what are the concerns people have about this system? What are their perceptions of it? And perception is all, isn't it? It doesn't really matter what the facts are. What's the perception of this? Do people have specific complaints? And even if they do, are they valid? And then have there been incidents? Any sort of incident? Business incidents, upsetting clients, regulatory incidents, production incidents, all those things are quite important things to take a look at. Rid of Zoom windows. Then there's the quality attributes, all the non-functionals that we know and love. We can work out where we are by measuring the artifacts we've got in the system. For example, have we got any security vulnerabilities? We get that from static and dynamic analysis typically. And also all the operational measurements. What is the actual throughput we achieve? What happens when the system's under heavy load? Have there been any security incidents and so on? And the other thing we have to understand is what's the prioritization across these? We can't prioritize every quality attribute. There are going to be trade-offs whether people like it or not. So we're going to have to bear that in mind. And then what is the structure of the code? Oh, sorry, what are the characteristics of the code, not just the structure? What is its structure? How has it changed over time? Can we analyze, for example, commit histories or source code history possibly, but especially commit histories to work out how it's changed over time, how it's who's been involved, what have they done, what kinds of change has it enjoyed or suffered, and then how complicated is it? And going beyond traditional psychrometric complexity there, we want to look at things like cohesion and coupling and dependency analysis. What are our third-party dependencies? All those kind of things, because all of that are constraints on what we can do to the existing code. Once we've got our sort of situational awareness, like where we really are, the second step is, why are we bothering to do this? What are the benefits of changing this system in a fairly fundamental way? So what we're trying to do is justify what is going to be a large-scale investment program, but also possibly large-scale change. Because change, of course, changes the organization as well as the software. And the organization actually has a lot of cost, both opportunity cost and real cost, in change. Key advice here, having tried this a few times, is keep it simple. What will you be able to do tomorrow that you can't do today? Can you enter new markets? Can you process more business? Can you provide clients with a different kind of service? Can you provide internal teams with information they don't have today? And why does that matter? Because everyone, if you offer them new facilities, will say it's a nice idea. But actually, why? What is that going to enable? And who cares? Clearly, some people caring is more important than other people caring. That has a lot to do with politics and power, but it's the reality, is that some people are just simply more influential than others. Those who care, though, especially those who are loud and powerful, the question is, can they tell you why they care and how much they care? One of the things I repeatedly had when working in front and middle office systems in a bank was being told that it was really, really important we prioritized all of this new change in the next quarter by June. You'd always go, why would that be? And they went, this new product, we could do it before anyone else. It could be really important for our trading line. Oh, that's very important. How big for the trading line? Oh, I've no idea, but really important. You mean what, 5%? Look, I've got no idea, but really important. The number of times we built it, and then we could see the trading line figures as well as them. I think they sometimes forgot that. It made damn all difference to the P&L. They might have done a bit more volume, but they weren't even making money on it. But to them, it was important because they hadn't really thought about the opportunity cost of it. So always ask people to quantify the benefit, even if it's a rough order of magnitude. It helps to choose between those. The key thing is don't get dragged into a company strategy exercise. You might need a company strategy exercise, and that's fine. Just get someone to go and do a company strategy exercise and maybe hold the modernization until they've decided that, because the two things are completely different.
Is this a good point at which to interrupt?
It would be, yes.
In which case, could you please put up your hand if you want to stay and eat pizza? 2, 3, 4, 6, 7, 8. And any special dietary requirements?
Veggie, please. Veggie?
Yeah, I always want a half vegetarian or vegan.
No.
Okay.
Can I ask you a question about
Definitely.
strategy piece? It's actually how often does this come about as the result of some strategic focus group that's said, oh, here's the new strategy, therefore we need to change this. Is this something that ever happens really?
I haven't seen that very much. Normally what strategy groups are big picture thinkers. And so what comes out of that is we'll be needing an entirely new end-to-end platform. Of course, everyone in IT's heart sinks because they've been on that kind of program before. This tends to come out of actually quite operational stuff. It's like in a bank, it's the middle office group. In like travel and logistics, it's the deep water shipping group. It's someone like that going, we can't really do any more business because as soon as we get a busy day, we're already staying an extra 2 hours to catch up with the backlog. And we don't think it's that complicated, but it's because we cannot move this to this or transform to this fast enough. So it's quite a tactical thing. And then everyone stands back and goes, yeah, you wouldn't know this, but actually that's for quite complicated reasons. And that then gets the whole kind of question running about how did we get here? And do we want to continue investing in this? Because this is a big change. Like this is rewriting the logistics optimization engine. That's like, you don't have to work that out the team. Do we want to do this or do we want a new system instead?
I do have another question, which you might want to. It's kind of the same nature, but you're talking to a certain type of organization that's isn't using, I presume, isn't using or off-the-shelf type SAP thing to do the plumbing. Talking about a more homegrown operating system.
Yeah, I'm pretty well
sort of thing.
Talking about operational systems which are custom built. They could be custom built in things like low code or Salesforce, but yeah, it's probably not SAP. Or I don't have experience there, but it's not one.
Just sort of the framework. Yeah,
it's definitely custom software. I should have said that. As they asked me at academic conferences, business systems, not nuclear power stations or submarine control software. So stuff that processes transactions fundamentally.
Sorry, would you be touching on the no code, low code?
Not
side of things?
specifically, but I sort of can do, but
Okay, just
yeah.
since you said it, just.
I'll jump in when it seems relevant. Yeah. Yeah. I do have some experience with it. One handy technique is impact mapping. One of the problems we sometimes have is we want to, for example, completely change the structure of the database and how it's indexed, because that will make life better for a lot of people. When we tell the business, great news, we're going to spend the next 3 months using most of your development money to refactor the database and put in new indexing. Actually, they look at us a bit blankly, don't they? They go, well, that sounds lovely. Anyway, about the changes I wanted in the UI. You go, no, but this is all for, it's very hard for them to draw the dots, to be fair, it's sort of understandable. So you may well come across impact mapping as a nice, really simple technique to help them visualize it. So we start sort of with a why are we doing this at all? And then who's going to be involved? Who either needs change or is actually going to perform change. So for example, improve our reputation with clients. Development team will do some stuff, your sales will do some stuff because they actually deal with the clients. How are they going to make things better? Well, the dev team, we're going to have less than one late reports incident per month. Don't know exactly what that is, but presumably it's client visible and you've delivered information late or something, and it happens regularly, clearly. With sales, they've decided they're going to take better sales ideas to the clients because the clients currently think they're being treated rather generically, so they tend to talk to other companies. And then what are we going to do to actually deliver that? Well, in this case, development are going to implement a feature called resilient delivery, presumably that's something to do with delivering information more resiliently, and they're going to add a report data cache. Obviously, in the right context, that presumably means they won't have any more late report incidents. And the salespeople, they'll have to have this done for them because this sounds like development work, but they need analytics for customer risk profiles, and they need to be able to profile customers with their areas of interest. So if we started here telling them we're going to have resilient delivery features added to your system, you see they'd have to do a lot of dot joining. But because it's in the context of this is to do with the late report incidents, do you remember those? Yeah, remember me telling us about those. They're not good, are they? Right. We're going to do this. It's all part of our client reputation. And also, we're also doing work with the sales team. And of course, a big one might have quite a lot more than this. People can see that there's a lot of individual bits of work which by themselves they don't really understand and don't really want to understand. But they're reassured that all of this adds up to something that they deeply care about. So that can really help people understand the benefits of all these bits of technical improvement work we want to do, draw them together. Step 3, I'm not going to talk much about this because technology people, engineers tend to be very good at this. Find the remediation options. Normally people have no shortage of ideas as to what they'd like to do better next time. So we obviously need realistic options, but we can have tactical improvements. As we said, we could do strategic improvement. We may be looking for an incremental rebuild. So we need a module by module roadmap for how we're going to replace them one by one. And then parallel rebuild, in a sense, the build is the easy part. We will use modern architectural styles and technologies, and we'll do it all right this time. We won't cut any corners. No, we promise. We definitely won't cut any corners. But the question is, how will we do that build incrementally, get value as early as possible? That's typically very difficult with large platform systems. But most importantly, how will we migrate workload onto it? What's the strategy? Again, in large banks, we have very, very standard approaches for how you migrate stuff onto it. But very, very frequently, especially more complicated parts of the bank, do get tripped up by it's quite easy to do 80%. It's quite hard to do 90%. It's really difficult to do 95%. And when we start out, we don't know how we're going to do the last 5%. Some other businesses, such as logistics and travel, airlines, for example, they can have this. They have very, very dark corners of their systems to do with handling VIP customers on routes across the world involving multiple code share airlines. And you sort of think, oh, that sounds quite difficult. And they go, oh yeah, let me draw you a picture. It's this difficult. And then you realize that some of it's on a third-party mainframe, some of it's on their AS400, and some of it's on their new Java system, which was finished 18 years ago. And they really don't know how they're migrating that workload onto your shiny new .NET system. What we need to do is to try and give people an idea of the implications of each option. So we clearly map out what the benefits are. Here are things we can do. Here are benefits. Ideally, if we can, with at least guesses at improvements, reductions in time, reductions in risk, those things. And then in particular, what's the scale of it? How big a change is this? How difficult is it to do? That's often the thing about who could do it. And then what's the risk? The scale tells us how disruptive this is likely to be in the system. It could be a relatively simple change. To give you an example, if you've got a system with very many components and you need to change one open source dependency, OpenSSL, for example, across hundreds and hundreds of moving parts, that's a big change, but it's not difficult. Everyone knows how to do it. You shut down the server, you swap DLLs over, start the server again, check the log. That's it. Anyone can do it. You can automate it easily, but it's very big. So the chances are something might go wrong while you're doing it. On the other hand, it could be a very intricate, difficult thing. If you tell developers they're going to move from one JavaScript framework or one major release of a JavaScript UI framework to another, you can normally find them finding excuses to book holiday because it's really fiddly, difficult work, and most of them don't enjoy it. And possibly you've only got a few people who can do it. Might be very isolated change, maybe just your mobile app, or maybe even just one of your mobile apps, but it's difficult and therefore high potential for one, only certain people being able to do it, and two, people making mistakes. And then there's the overall risk. Is this something that's going to go wrong? If it goes wrong, what's the implication? Are we going to take the business down, or are we just going to slow down the Instagram feed for a couple of days? Once we've got some options, we can then think about what's going to go wrong. What we need to do here is identify what could go wrong, and then understand what is and isn't possible. And obviously the risks, with credit to Donald Rumsfeld, who for some reason got pilloried about this, totally unreasonably. Where are the areas where we know we don't know the risks? How many areas of the system do we understand so poorly we don't even know if we don't know the risks, the unknown unknowns? Every large legacy system I've ever worked on has had dark corners like that. If you do source control analysis, it's the bit that hasn't been changed for a long time. And when it's changed by one person in very small steps. You go, we probably don't understand that corner, do we? And everyone looks at it and goes, no, we don't go in there. That's best to just leave it well alone. Often the corner of the database schema. It's the sort where the data column has got impossible dates on it because people have encoded numbers as dates and put them in the column because they didn't know where else to put them, that kind of thing. Key thing for most systems is, do you understand your integration points? You've probably got links with other systems. Do you understand how they work? They're often undocumented after all. And there may be, even with simplistic technology like IBM MQ or files, there may be some intricate protocol for how that actually works, which isn't written down. And Mike and Claire and support kind of understand it because they tend to fix it. And actually, they may not understand all the special cases themselves. It's the kind of thing where you go to Claire and you say, that fix feed that we send out by file to that big client? Yeah, she says, oh, that's awful. Yeah, we're going to replace it, aren't we? Yes, but do you understand the log files? Yeah, definitely. Yeah, we just delete them if it goes wrong. Does that always work? Yeah. What? Except if there are two data files. We've never quite figured this out. If there's two data files, we mustn't delete the log files. We create another one. And we don't know why, but somehow that unblocks the feed. Right, we don't understand this, do we? No, now you mention it. No, we don't really. And that's really, really common in any big organization. It's just that knowledge gets lost. Stuff is done to solve short-term problems. And you've all been there. Stuff just gets lost. Do we understand what each bit of the system does? Stand back far enough. Of course we do. Processes, transactions. Get really close to it. Why have we got special logic for tax handling in Austria for packages dispatched from the UK? Oh, that's probably to do with a tax treaty. Do you think? Do you understand it? Not at all. But this is your bit. This is my bit. Do you not change the Austrian code? I try not to. Those kind of things where, yes, we understand the function sort of strategically. When you get into the detail, we may not. And if it's an old system, we've almost certainly not got tests, or not good tests that actually tell us what it really does. So then, of course, there's hunt the SME. There's hunt the person in the organisation who actually does know. Yes.
Given that you define new as 18 years ago, what's old?
Oh, 40 years ago.
COBOL.
That SME
Yeah.
was probably made redundant last year.
Exactly. Or just retired, happily retired. Yes, you try and tempt him back. And no, I'm very happy now living on a beach in the West Country. I have no intention of touching a mainframe ever again. Yeah, systems written in PL1. There was very little PL1 written, I believe, after about 20 years ago. Assembler, I worked for Ford Motor Company as my first ever employer. Very interesting place to work. Had bleeding edge systems, really experimental stuff like symbolic workstations. And we had stuff for the manufacturing plants where at Ford, one of the last IBM customers, I think in Europe to phase out punch cards. Not because punch cards were used for main processing, because there was assembler code on the mainframe in the manufacturing control system that was running Merkenich and one of the British plants, probably Dagenham, where the way that the cars were tracked through the plant was a punch card was printed out at the start of the line and it was taped onto the car. And that punch card at certain strategic points had to be taken off and put into a punch reader, but back on. Now, obviously, every other plant in the whole of Ford at this point was using barcodes, QR scanners, lasers, just these guys. Well, it's all working. And, we don't really want to invest in this plant because its future is unknown. So we'll just carry on using them. And it was, I think they were still talking about replacing them when I left Ford in 1990. So that's pretty recent for punch cards. And then the $64,000 question when we're thinking about renovate or rebuild is, can you change all of this reliably? The answer, quite honestly, to the old system is almost certainly not, in my experience. However, the more interesting question is, for an acceptable amount of money, could we make it reliable to change? So could we put enough testing in? Could we reverse engineer enough of the mechanisms? Could we put a continuous integration pipeline in so we get continuous checking? Could we modernize some of our development practices so that actually, although it's a bit old, we actually could change it reliably? Because that could completely change the calculus of our decision. Well, the answer may be no. This is too complicated. We haven't got the SMEs. We just cannot write enough tests cost effectively to make this safe to change. So risks are obviously things that might happen. Constraints are things that have happened. How much money have we got? If we haven't got the money to replace it, there's no point proceeding. So that we need to first. How much risk and change can the organisation bear? If you've just done a merger, for example, with another organisation, your organisation is likely to have a huge level of change fatigue. Everyone's had enough change for the next 5 years, thanks very much. We'd rather just get on with serving clients and doing a good job. We don't want any more change. In that situation, clearly you would want to be much more conservative about the change you inflict on your operational users, for example, than in fact if they've been stable for quite a long time and actually they're quite bought into the idea of changing this because it's causing them problems. Certainly at my time in big banks, we had both situations. We had offshore teams doing securities processing who were desperate for change. They knew this was inefficient. They just wanted to do things that, they wanted to stop copying data around really, or having to remember at the end of the month to flip a load of flags. They just wanted stuff automated. So they were quite happy to change. Then other parts of the bank who, there was one particular part that did futures and options. They just had a merger with a competitor. They'd been through a 3-year program to integrate the IT systems. The business, never mind IT, had really had enough change. Thanks very much. We've just about got this working now. Don't change anything big. And that was very much the instruction. That was a real organizational constraint. And then your team, the team who are going to have to do all this hard work, all this heavy lifting to actually make change. Are they capable of the kind of change that you're envisaging? Can they develop 2 systems in completely different technologies at the same time while keeping the lights on and doing a great job of the new technology? Do they need skills? Do they need space, time, training? Do they need the right attitude? Do they need some enthusiasm injected into the team? Perhaps the team has been in a really bad place for quite a long time. There's loads of techniques to analyze a trade-off. They run from the quite quantitative through to the very, very qualitative. And quantitative ones are things like multi-criteria decision analysis, statisticians, all done in TDA, I'm sure. Decision trees, which are, try and put links on them, multiply them up to work out what our the likelihood of decisions is. Then there's the more qualitative things. We can have pro and con lists, and we can put weights on them. That's 3, that's on the spot. Trade-off matrices, which I'll show you in a moment. Scenarios, architectural scenarios, so stories that tell us what the system does, what the system is meant to do in a certain situation. They're very good when dealing with non-technical stakeholders. They bring things to life. And then what's politely termed cognitive. I don't think these really these are really terribly useful techniques because they're so subjective. But opportunity cost analysis, in other words, guessing the future. Economists love to do a bit of opportunity cost analysis. I did do some economics in my background. I could never work out why this was really fundamentally different to throwing dice. You can simulate the future, but there are so many unknowns in most situations. Actually looking at long-term opportunity cost is very difficult.
2 points on this slide.
Yes.
One is if Tom Gill were here, he'd be telling us that you need to use language. And,
he would definitely talk about language, yes.
Tables.
Yes.
And the other point is, we've recently had this debate about prostate cancer screening. That's very much an example of the opportunity cost analysis, because if you do that, probably here we're often looking at parts of the
that's where I think it runs into problems. The other one I was introduced to a while ago, which I thought was quite funny, is the 10-10-10 rule. You come across that? We call it the 10-10-10 rule.
Oh.
It's a cognitive trick. Apparently, if you want to work out whether somebody really believes a decision or not, you ask them, how do you think you'll feel about this decision 10 minutes after you leave the room? They give you an answer. They say, how do you think you'll feel about it in 10 weeks' time? How do you think you'll feel about it in 10 years' time? Apparently, this is meant to trick the brain into thinking about it through different perspectives because of the different timelines. I'm not totally convinced, but your mileage may vary. It's certainly psychologists recognise it as a technique that they use in corporate decision making.
And different coloured hats.
Edward de Bono, yes.
De Bono, yes.
Yes, absolutely. So the two that I found repeatedly that technical people are good at, trade-off matrices and scenario analysis. So when you look at trade-off matrices, these are where you've got a number of factors in a decision. For this particular one, we're worried about what's the migration risk, what's the business change risk, what effect will this have on the user experience, and what's the ease of feature change. How easy will it be to add and remove features if we do this? And then we look at each option. We've got 4 options here. It's something to do with reporting. And we can add a reporting database. We can upgrade a database and schema extension, build a new one, or integrate with reporting services. All we do is we use these qualitative measures. And I'm a great believer in using high, medium, low, small, medium, large. Because if you put numbers in, people tend to try and start adding them up, finding averages, maximum of it. It's just really meaningless because they're qualitative measures. They're Likert scales to a statistician. But having defined these, you can define what good and bad is. Good, medium, and bad. And you can use colours to just give people some visual feedback as to the balance between the different ones. And so, one is more green. It's not that you'll ever get all green or all red, but well, actually one is all red. But it's more green versus more amber. That one's got some red. That looks risky. Do you think we should investigate it? The advantage of this is that the technical people can agonize about the individual item. When we're trying to explain to someone who's not with some decision, through the colours, they give them some visual feedback as to why we have chosen a particular option, and perhaps gives them feedback to things like, well, we had a lot of options that are quite similar. Or really, there was one option that stood out. The others really weren't worth considering very much. They can get that quite intuitively without understanding the detail. And then finally, we need to get to a stakeholder-led decision. So we need to use all that data and insights, our context, our concerns, our options, their trade-offs, risks, and constraints to help stakeholders make a good decision. And to do that, we need to have a clear strategy. How are we going to make a decision? Is this a democracy, or is it a consensus, or is it loudest person in the room? Or are we going to consult people and then come back and tell them what we've decided? There's lots of strategies, lots of books on that. Try and get people focused on the facts. Keep reminding people, what is the context? What were the concerns? What are the constraints that they cannot move? What risks do they need to bear in mind? Keep explaining trade-offs. Trade-offs are second nature to engineers. As soon as we see something, we go, yes, but. Or you might think that, but I can think of something like it's just second nature to an engineer. It's not second nature to many people who are involved in these decisions. They just don't think that. So you keep on reminding them of the trade-offs. And try and avoid all the distortions that come into most decisions. People's perceptions, assumptions, all the biases people arrive with, the loudest voices in the room, people who are particularly good communicators versus people who are actually thinking very deeply, all those distortions. So that's the approach. Work out where you are, work out what the benefits are, work out what the options are, work out what will go wrong, your risks and constraints, and then drive the stakeholders to make a good decision using all that information, which in itself is quite a tricky process. It requires knowledge and experience. So I've got a little case study to hopefully bring it to life. So this is a system with some problems. This is a merge of about 3 banking-based systems that I worked on during my career. If you're from capital markets, this is a trading support platform. It's middle office. Delivery, this is very, very differentiating. They can't buy one. It's largely unique. They've built it for themselves, does exactly what the business need. The business really, really like it from that perspective. Delivery velocity, though, is really, really slowed. It's getting very hard to get new features into it. People are getting a bit frustrated. And it used to be really reliable. Now it goes wrong quite a lot. So you can imagine that causes a lot of concern. It's pretty complex. It's large, but not huge. 600,000 lines of code. Uses many technologies, Java, Oracle, C++, a message bus. Pretty database centric. You can see the functional components kind of circulate around the database. And it's very connected to other parts of the bank. This is clearly a simplification here on a slide. But, each of the dots is input or output from another part of the bank. So if you take this away, lots of other things will go wrong because they rely on data from it or rely on sending data to it. So we need to understand our context. So just 2 of the important things are, we're a highly interconnected part of the technology in the organization. And we're used by quite specialized and, more importantly, very influential user community who, if they're unhappy, they will not be shy about telling us. More importantly, they will not be shy about telling the head of the business because these people make a big difference in the business. They're the middle office after all. In terms of the concerns people have, the middle office people they're reasonably happy. They love the specialized UI, which is a bit quirky because it was built around them. But they want reliability and they really want to get feature delivery back. They're getting a bit twitchy that they cannot get their changes in. Done some surveys across the organization. Most people are actually worried about delivery speed, performance, and reliability. There's lots of other things they talk about, but actually that's what they really are caring about. And we've had a look at the defect and reliability incidents. They're not great. And but in that we've noticed that most of them are actually database related. It's not like the message bus loses messages or the calculation service crashes a lot. Actually, nearly all the serious incidents have got something to do with the database. So therefore, we kind of know what qualities are important to people and what people are upset about. The code analysis indicates it's complicated, but it's quite modular. There are quite a few security vulnerabilities, but this is buried in the bank, so we can review these over time. Complex database, difficult structure, and very complicated queries. And the developer experience isn't great. Or limited deployment operation, not very good testing. So the question is this worth changing, or should we just soldier on as we are? Well, the business are very clear. Every outage costs them money because the business stops. And every new financial product or feature we can put in, they say, well, we only ask you to change it because we'll make more money. We don't ask you to change it for fun. So we definitely want this to get back to rapid evolution. The tech ops team will say, actually, if this system's become a bit of a pain, we used to ignore it most of the time, and now we reckon there's 2 FTE are looking after this. That much babysitting. So if you could improve it, that will definitely reduce our costs, which we would like. And the development team, well, they know where they are. If we could make things better, they'd be able to deliver features quicker. That would improve efficiency. So we've got a pretty good clear financial benefits. So then we say to the team, well, there's definite benefits here. You understand the context as well as anyone. Let's go and talk to some stakeholders about their needs, but let's look at what the options are. And the two options are a strategic improvement program. The team want to split this part into two. They want to build a mobile app because it allows them to iterate really fast. They want to completely wrap the calculation service inside a risk service, take some more stuff out of that. They want to split the databases, partition the databases for performance. So it looks like roughly the same system, but there are quite a few changes, and they're quite big changes. You know, particularly the trading support service is going to get broken into three, so that's quite a big change. What the team really want to do is a parallel rebuild, because they'd really like to use microservices because they've not used microservices yet. And they're going to split all the data across 5 databases, because why wouldn't that work really well? And they'd like it to be cloud native with an API gateway. And they'll build most of it in Java, but they'll keep C++ for the calculator. But they'll build a brand new calculator in modern C++, and they won't make all the same mistakes. Which, of course, is a bit different. I mean, that is quite a big change. That's a brand new system. And the risk and constraints, well, the complexity, it's kind of hard to rewrite 600,000 lines of code that doesn't have great tests without introducing a load of errors. And everyone's worried about that. The developers are worried because they'll be pulled out of bed because the numbers will be wrong. The business are definitely worried because they'll come in the morning and all the numbers will be wrong. Making existing changes in the existing code is quite error prone. And this is why the team want to push for the new system. Well, one, they want to use all the new technology because it looks a lot more fun. But actually, they are a bit worried about changing the existing code. As they say, big refactoring of the big monolith. They're a bit worried about splitting that up. Migrating to the new system, compliance, business ops, corporate risk, they're quite concerned about that. And client service don't like the look of that at all. In fact, you'll be running on 2 systems, you have one client on 2 systems, possibly for a significant period. They can see all kinds of things are going to go wrong there in the client systems, and they'll get the complaints. And then from an operational perspective, a big change to the existing system could cause more outages. Actually, tech ops are a little bit concerned about this, splitting the database business. They're really quite concerned that's going to be more complicated, and there are going to be data migration problems, and they'll get called in the middle of the night because the reconciliations fail, and they won't know why. So they're a bit concerned about that. The risks are that the team don't have much automation experience. Skills. Some of them know Java, some of them know JavaScript, and some of them know C++. Most of them don't overlap very much. They've tended to live in their silos because those technologies are very different. For integration, the bank clients don't want any change to the integration. They know it's not very modern. There's a lot of file transfer, but they don't want it changed because that implies big changes at their end, and they're just not prepared to do them. The user experience actually today isn't bad. Everyone looks at the interface and thinks it's very archaic and difficult. Actually, the people who use it are the people who defined it. They absolutely love it. They think it works really well. And the current technology, well, it's quite widely understood in the organization. Some of the things the team are proposing to do, changing integration approaches and changing databases, actually the central engineering organization are not very enthusiastic about. So what happened? Well, got to a stakeholder decision. Some of the big things were, how about our refactoring risk versus our migration risk of a new build? How about the risk of refactoring versus replacing business logic, having defects in new logic? So we can have defects in rewriting the old logic, defects in a new system too. Disruption, either way, this is going to be disruptive to someone, somewhere. But the benefits we're promising, will they really repay that disruption? How about the business change risk? There are going to be changes. The middle office people will be affected, client service will be affected, probably sales and trading as well, certainly compliance. And we're going to have technical change here, whether we like it or not. Have we got any team risks? So that was a big topic of discussion as well. So the business, the technical operations people and development were all involved in the decision. So what happened? Well, this is slightly simulated, but in this particular case, this is actually what happened in at least one of them. The decision was to do the strategic improvement program. So that's take the existing code, break up the monolith, and cluster the databases, build the mobile app, and so on. And over 12 to 18 months, actually, the system was systematically improved, and actually it got to a much better place. And most people were actually quite happy with it, and they managed to keep the risk under control, which was the absolutely key thing. There were no major change rate related outages during this time. The reason they got to that was when they thought about it and worked it through, they were very concerned about migration risk. That just seemed to keep getting bigger and bigger. They couldn't change the external integration. So nobody really liked the idea of recreating 40 or 50 legacy links in the new system. That seemed to be an awful lot of wasted effort. So that was a big decision. And when they thought about building the whole new system, about 600,000 lines of code, they were going to have to, without a test suite to start with, they were going to have to find a way of rewriting that in new code, presumably a better approach like domain-driven design, while not introducing any defects. And the whole dev team realized that was going to be an almighty challenge. It's very unlikely they were going to manage that. So that's what led them to, let's improve it strategically, as opposed to muddle along as we do now. So the key principles I've found during these processes are data collection and analysis look expensive, but actually they're key investments to make a good decision because they provide the facts. You need to find benefits early. Two reasons. One, it provides good context for the decision. The benefits are quite small, therefore our ambitions have to be limited, or there's massive benefit here, we have to take this very seriously. It also keeps people interested and engaged. Because if people don't really understand the benefits, it becomes the technical group talking to the technical group about all the cool tech stuff they can do. And that is rarely what leads to a good decision. Make sure you consider all the options. If it had been left to the dev team, they would have considered precisely one option. The new system with the services and the new database models and all that, because that's really what they wanted to do. It was only when they went through this quite structured process, they realized that actually there were a load of risks there that they realized that really wouldn't bear, never mind the business. Stakeholder communication is really important because we need to explain to people the implications of what we're doing. We need to make sure that they feel part of it on our side and that they're taking their part of the process. And you want an architecture-driven decision. That's my thesis really, is that a lot of this is architecture work, but we want a stakeholder-led decision. So driven by senior technologists, but we want the stakeholders believing that they have made the decision, not they were told what the decision was. And those are the 5 steps that I think lead us to a more rational approach to renovate or rebuild decisions. Some of the skills that are really important are data analysis skills, trade-offs, being able to identify good options, understanding and trading off between quality attributes and how you achieve them, and being able to communicate well with stakeholders. And all that allows us to achieve these evidence-based decisions. There are a few references if you want to delve more. Nick Tune's book I mentioned earlier, which is more at the EA level, is Architecture Modernization. Nick Tune, and I'm afraid I've once again forgot his co-author, which is terrible. There's a fairly new book. Forgot their names as well. That is very embarrassing. German lady and German guy. I'm back. Who've just written this for Alison Wesley. It's just been released weeks ago. Apparently, my copy's in the post. I'm looking forward to it. This is a much older one from the SEI, and then these 2 books are a bit more tactical. They maybe don't have a grand plan about them, but they've got lots of good advice and a couple of websites across the top. People who know me may be very surprised to see that one of them is Gartner Group. It's not often I quote something from Gartner Group, but they do actually have. It's a little bit trite, but they do actually have a nice little. They call it framework. It's a list. They do have a nice little list of 7 ways you can think about modernizing systems, which is worth a quick look. Thanks very much. I hope that was interesting. Happy to take any further questions.
There's a question online from Peter McElwain.
Jolly good.
Great talk, Ian. Thank you very much for taking the time. I've been teaching architecture decision for over 15 years. Oh, hang on. Good. Oh, yeah. I've learned from you this evening. Lots of questions.
Thank you, Peter. That's good to know.
Yeah, people online, please feel free to unmute and ask a question. Ian, you want to say something?
Hello, Ian Cornwell here. The absence of tests was acknowledged to be an obstacle for change. So attempts to add tests to large legacy code bases are presumably not uncommon. What do you think of attempts like that? What's your experience with that, or what have you heard when people have tried to do that?
It can work quite well. I mean, it can be a real enabler for change. Problem, there tend to be two problems. One, an old system may have been built without thinking about testability, so it may be quite hard technically to do that testing.
Yep.
Sometimes you can wrap it, and so you can have what look more like integration tests, but you're sort of using them as in unit tests almost. The other problem is that it costs quite a lot. So although people start on the journey, they run out of money, time, enthusiasm as they're doing it. And that's, I think, sometimes the biggest problem is that they could make this system more testable. They could make it cheaper to change, but actually no one wants to pay for it.
Yep, thanks. Yeah. Another separate question is, I got the impression that most of the time there was an assumption you're talking about like a single unique enterprise system. What if you're talking about a product with maybe multiple instances, but the product shares the same issues that you describe, falling productivity and these things, and the rebuild versus improve discussion comes up. Is that something you've thought about? Do you think, I mean, a lot of your advice would equally apply to the product case, but any specific thoughts about how things might be similar or different for products?
I think it's a very similar thought process. And technically, you go about it in a very similar way. But thinking back to my time in products, the problem is you can't really canvass the buyers of the product, the customers, unless you've got a very specialist product with, there are really specialist products like data products who've got literally 20 customers. They probably could run a user forum and involve them, but something like a database, mass ship thing, you can't really go and ask them. So you're reliant on your marketing, customer success, developer advocates, those people to represent for the customer. And the risk, of course, is that they're not really reflecting the true views of the customers. The biggest problem I've had, this was when I was at Sybase, was there were things we wanted to withdraw or modernize, and we just had enough of the customer base tell us they weren't going to do it. And we said, well, it won't be supported. And they'd go, okay, we're still going to do it. And then when it goes wrong, we're going to call you anyway. Because they were big customers, you knew that something was going to have to happen later. You could pretend you wouldn't answer the phone, but in reality, if they were still customers, you would, because they were still paying for it. So that was a major blocker for lots of change. I mean, certainly Sybase back in the days when I was there, we had some really odd things in the product catalog for no reason other than we couldn't persuade clients to get off them. It seems to be a cost of doing business in product. I think SaaS is changing that SaaS and cloud, because they sort of force the change on people. But certainly with shrink wrap products you ship out to people, they get embedded in the organizations, and it can be very hard to get people to move.
I mean, my interest was that small, like 10 instance category.
Okay.
Where you might feel that you can't talk to your customers because it's bad news for your customers. But in fact, when you were speaking about talking to the stakeholders, I thought, well, we should. We can and should, because like you said, they are going to pay for it, even though it might not be presented like that. Ultimately, they will pay for the change. Yeah.
So if you had 10 customers, I completely agree. I would just treat them as individual stakeholders and try and run I don't know, some kind of decision user group or something like that.
Thanks.
I worked for 2 years on a project where a big bank wanted to basically redevelop its platform for selling mortgages. They gave us a long list of things that were wrong with the old system, but they said, the minimum viable product is something that supports all the features of the old system. In the end, what rescued the project was the fact that we'd involved some of the branch users early. and got them to take part in sort of user interface prototypes, and they loved it. They loved the new experience, and they actually put in a very strong word when the bank threatened to cancel the project.
Right, so
They
they
said, no, we need this.
became advocates. That's perfect, yeah.
Well, so you made a couple of, well, I think were jokes or amusing remarks anyway about the techs wanting to use the shiny new things, web services or the new database or whatever. To what extent do you think that's still a big driver in this?
Constantly. People want to use new stuff, yeah. Yeah, I mean, everything from so are we being recorded? I'm not going to tell that anecdote. Yeah, I mean, development teams literally rewriting parts of systems in new technologies without telling anyone because they wanted to. I mean, they thought there'd be big benefits. To be fair, it wasn't just for their CVs, they thought there would be, but just literally going and doing it. Through to people who at the other end. I remember working for one particular finance organization, big investment in Oracle databases. So there was a community and culture of Oracle DBAs. They had staked their entire careers on Oracle databases. And then there was a big move, in theory, a big move was planned to another sort of database. This group, of course, were incredibly passively resistant to the whole thing because they had staked their whole career on Oracle databases. So yes, absolutely. I mean, I think technical teams, you can sort of rely on their professionalism to a certain degree, but human nature is either I love this stuff and I want to do more of it, or that's a shiny new thing, I'd like to go and use that. And people will bias their decisions. That's why I mention it, because they'll you give them their decision matrices, and suddenly a load of things that bias towards microservices get extra points because they can see the way the matrix is going, and they go, oh yeah, it'll actually be high, not medium. And suddenly it all turns green. You think, well, that's a bit suspicious. You want to do microservices. Suddenly all of our decisions seem to point towards microservices. And yeah, senior people step in and go, I don't believe you, challenge it. There's nothing wrong with wanting to work with new stuff, to be clear, and that there can be real benefits as long as it's part of a reasoned decision. Yeah.
From my experience in IT project and program management, I came to the conclusion, this is not a question, this is an assertion of fact, that it is impossible to put together a plan and a budget that is both accurate and acceptable. Now, the question goes, if you are looking at your alternative approaches to modifying your systems, they're based on budgets and plans that can be either acceptable or accurate, but not both. How do you overcome that challenge as part of the decision process?
There's a mental model for large-scale change used in enterprise architecture. It comes from Archimate, called plateaus of change. The idea behind it is if you've got a large amount of change to do, you want to go from A to B. You might change the direction, but leaving that complication out of it. Rather than simply doing change constantly from A to B, you need to identify the smallest credible step that takes us towards B, get to there, and make sure that the point of the plateau is we could stop change now. We would have delivered value. And then we work out what the next change would be, and it takes us to another plateau. And that's it doesn't physically change anything. It's a mental thing. We're thinking, when we get to the next stable state, could we stop? And if we can't, what do we have to change so we could stop? And we try and plan it in terms of abandonable increments, I call them. I think there is a more technical term for them, but it's increments where if people don't keep funding, we can stop, but we've still done a professional job and delivered value. Our role, I think, as technologists is to try and get a product kind of mindset, which is, think about this as a rolling investment program. If we're continuing to deliver value to you, presumably you'd like to keep investing. If we're not delivering value, you are absolutely within your rights to withdraw investment. Of course, to do that, we have to make sure that when they withdraw investment, we are leaving them in a responsible position where they get benefit from the investment they have made. And that's how I guess I would go about that. Is I understand the problem. I mean, I've seen it before. This is going to cost 8.4 million francs. Well, we can't tell them that. That's what it's going to cost. Tell them anything you want, but it's going to cost 8.4 million. Yeah, I absolutely recognise that problem.
Planning bias.
Yes, exactly. There's a question in the corner.
Yes, thanks for your presentation. It's been very interesting and quite good points as well. How does your methodology differ from the, I don't know whether you've heard of the ITIL, the infrastructure library, which is full of good practices, etc. And it's based more on the live system, which you would update or upgrade. They have things like change management and release management. More or less, many of the concepts you put in are used in that particular, I understand it. How does it differ from that?
It's a different emphasis. So, I mean, I wouldn't call this a methodology. This is just a simple process for how you get to a specific kind of decision. ITIL is an entire framework for how you do service delivery around an IT infrastructure. So this might be, I mean, ITIL doesn't cover this, to be clear, because it doesn't really do modernization, or does processes, but not really systems. This would have an impact on the people who are using ITIL. They would need to be, they need to understand the decision. They probably have input to the decision, and depending which fork in the road you took, they would have to consider what the impact on all of their ITIL-driven processes were. So they're looking at different aspects of old systems.
What about what's your view of platform engineering in the context of what you've just been talking about?
It's kind of orthogonal. If you've got an effective platform engineering team and initiative and movement, if you like, inside your company, that will be one of the inputs into your decision. There may be big benefits in getting our software onto the platform, and if we have that system I showed you, that's probably not going on a modern container, internal or public cloud platform. To be honest, it's going to be quite hard to put it on. So that might be, if not, I'm trying to think where it fits. Not exactly a constraint, but it's a trade-off. It's an incentive to go for a more radical modernization, because that will allow us to move into the platform world.
Are you, sorry if I have a follow-up, your remark about SaaS earlier suggests to me that somewhere there is a split between cloud and full cloud going on here.
Well, what I'm thinking about here really is the difference between cloud as an application platform. Well, it's three. Cloud is an infrastructure platform, which is probably what these people are thinking about. Cloud is an application platform, much more radical restructure needed. You're going to have to work in whatever way the particular platform as a service, the PaaS, wants you to work, which normally means in containers of a certain size, certain services, certain deployment assumptions. And then the SaaS is kind of what you see is what you get. We change the software all the time. You live with it.
Can you predict where things are going?
I think a lot of companies in the medium term will go to SaaS. There's a lot of people telling me that AI is going to kill SaaS. And it seems to be a very speculative theory that the cost of building software will be so low that even small organizations will simply, a ridiculous term, to get Claude code to generate their apps for them. So why would they use SaaS? It seems incredible to me that a small organization would try and replace Salesforce with something they coded in Claude. I mean, it just seems that they're different things. Claude would be brilliant at, well, one day we'll understand Salesforce. It'll be brilliant at like building small apps on Salesforce to solve a departmental problem that today is too expensive to solve. But like all the things Salesforce provides, everything from your marketing automation through your CRM, through customer data management, analytics, a small firm's not going to develop all that themselves with AI, because they wouldn't, even if they could write the code at acceptable cost, they'd have to evolve it, look after it, and run it. And that would be crushing cost for them. They need lots of skills and people they just wouldn't have. That's why you pay Salesforce, because I mean it's why we pay Amazon, right? Because we don't really want to employ all of those incredibly expensive people Amazon employs who are experts at this little thing that they do, which is what makes the platform so good. So I don't really understand that argument. I certainly don't buy it from my understanding of it. But I do think that smaller and medium companies, they're still in the transition, but they're pretty well all going to end up on SaaS for everything apart from the most specific applications. for their specific businesses. And those, we were talking earlier about low code. I mean, they might well develop those using low code, and I'm quite sure, I mean, all the low code tools are getting AI in them. OutSystems, I was at an OutSystems workshop, not to endorse OutSystems, there are other choices available. I was at a workshop for integration recently, and their AI system, they call it, is terrific. I mean, it can help. I mean, OutSystems isn't a very technical environment to start with, but it really helps someone who only half understands OutSystems to build a little OutSystems app really quickly and plug it into. They showed it reading data from a database and calling an API. They did it on stage in 50 minutes. It was quite a bit.
Have you looked at N8N?
Uh,
N8N? Looked at that?
Oh yes, not a huge amount, but yes,
It's causing an enormous amount of buzz at the minute. I think
yes,
it's got
absolutely.
some